Hello, this is Ashton once again. I'm coming to you with another like kind of a lesson or tutorial. So I have students that I teach C++ to, and they always ask me, what will be a real world implementation of C++? So finally, after years and years and years, I actually found a C++ web framework that I really like so far, and I've implemented it. And it's a real nice framework, and it's well documented. It's okay. It's well documented. I say it's okay on the documentation part, but it's called Oatpp. So in Oatpp, this right here is the actual web page right here. And you have the quick start, you have the about, the support, and then this is actually where the GitHub is. And just to look at some of the highlights of Oat++, you can run it anywhere. It is cross-platform, so I can run it on my Windows, I can run it on Linux, and there is a Mac implementation. And they claim it's a robust API. Which some of the implementation that I've seen, it is very robust and very flexible. Um, and I kind of like the way it's done. It's using CMake, and we'll get into that later. Uh, and I like the fact that I don't see this too much is the benchmarking. So they actually kind of do some of the benchmarking here for because you have a simple API and then you have an asynchronous API. So the simple API is your regular API that you do a request and response. The asynchronous API is more of a one job. This monolithic component does one job and one job only, and you have all of these different components connected to it simultaneously. That's why it says 5 million concurrent connections. So where you end up being like using a WebSocket. I like the fact that it has an ORM. This has been a big challenge in C++ for a long time. And the ORM is pretty much handling database connections and models and stuff like that, a framework to handle those things. And then the object mapping is very big, especially when you're using JSON. Um, and then they actually have a pattern for DTOs and stuff like that. Data to object models, and then they do have the document your API. This was a plus for me. The Swagger UI and the Open API 3.0, you can implement Swagger, and that's what I really liked about this API as well. So if we go and look into some of the benchmarking, so I like the fact that they actually did the benchmarking on a modern day solution, which, for instance, we no longer put things on bare bones systems. We actually use the cloud now, what we call the cloud, someone else's computer. And right here, they actually give you what specs you would need to hit the benchmarks that they hit. Um, and and it depends on the network connectivity and all that stuff. But I like the fact that they have benchmarks here. This is for the asynchronous, for the WebSocket tests. They did 4 million and they did 5 million. So right here, it shows you that this is the 2 million benchmark and this is the 4 or 5 million benchmark right here as to what do they recommend. And then this is actually where they talk about the load, the 2 million connections, and then the 4 million to 5 million connections. They explain a little bit right here, and they actually used the Google Cloud to explain some of the things that they have going on. So they built 4 million clients, and then they attached those 4 million clients to the actual server or to the server WebSocket. Okay, and see right here, they show a lot of the benchmarks right here, which is very great. I really like it. Okay, so if you keep going, they actually have examples here. What I'm interested in for this tutorial is the API. So this right here is, they say how you make a client. and then different little subjects right here. And right here is a microservice, which I'm kind of interested more into the microservice and everything. Okay. Um, and that's one thing I do like right here. You see how they have it where they have different ports and they actually break things into different services and break them into different ports. I actually like that as well. Okay. So right here they go through the installation. Like I said, you got a Linux and Windows installation. And then this right here is the entire tutorial on how to do the Linux and Windows installation, which this will be coming up soon. What I like to do in my projects is get them up and running quickly and just to figure out how things work and all of that. So then you have the Windows installation right here. What are the things you will have to do the Windows installation? And we get into that as well. And then you got the VCP packaging, and then you got the Conan packaging. I kind of like the Conan packaging so far. I like packages and building because when it comes to building and stuff like that, it's more sustainable, and it's more industry standard. Okay, but what we're going to do is get it up and running without the package manager. So right here they have quite a few getting started. They got some overviews on some basic things that you should know. One of the ones to point out is they tell you what is recommended for to use a simple. What will be your scenario to use a simple API versus using an asynchronous API? Okay, and they give like quite a few examples on how to change those around and stuff like that using the C++. Okay. And so right here, these are all the modules that they have available that's compatible with Oatpp or Oat++. And then here are some API references as to the code that comes with those packages. Okay. So now some of the requirements to get this started, especially in Windows. So if you go over to Windows, Visual Studio is recommended, but I would tell you this, even though they said 2017, I'm using 2019 and everything works very good, really good. They got CMake out here, and then they have Git out here. One that I recommend is actually using Visual Code as well. And if you look through here, this is to download the CMake, which you'll have the cmake.org/download, and I recommend you use the MSI so you won't have to like do a lot of it's easier to install. Okay, so then if you don't have it, the Git CLI is needed as well. And then right here you have the Visual Studio out here, where you have to download the Visual Studio. And then the download for the Visual Studio Code is something that I use extra. And then this right here is the JFrog, the Conan JFrog, which we'll get to this when we get to more of an advanced subject on hardening our build system. When do we want to harden our build system? I like to harden my build system ahead of time so that when we start to develop, we don't have to worry about our process for doing a build. Okay? Alright, so let's get started. Okay, so the first thing we're going to do is we're actually going to pull that clone down, and I'm going to do a bit of a copy and paste. This is coming from the installation page for Windows. So I pull that clone down. Whoops. See how it already exists. So what I'm going to do is I'm actually going to make a directory, and I'm going to name this directory Oat2 or something like that. I'm going to cd into Oat2, and then what I do is do my clone. Okay. Okay, so now that I've done my clone, what I'm going to do is, one second. Okay, so now that I did my clone, what I'm going to do is do a ls. I'm actually using the subsystem in Windows, the Linux subsystem. That's why you see that I can run some basic Unix commands and Linux commands to get around. So now that we pull down the Oatpp, okay, so we cd into the Oatpp, and then the next thing we do is we make the build directory. So what we're gonna do is we're gonna do a mkdir, and we just say build. Okay. So we made the build directory, and then what I'm gonna do is cd to the build directory, and then what I'm gonna do is I'm gonna do a cmake. Let's go and take a look at what all it pulled down first. So I'm gonna do a clear, and everything that it pulled down right here. If you notice, these are all the files that it pulled down. They have some things in utility as well. So what I'm gonna do is let's go into the build directory, and let's test out this tutorial and see, if we have any problems. Because I did a special build that I like. I actually customized it, and my build is not documented. So let's do a cmake and see what we get. So if you notice, it automatically picks up the Visual Studio for this. The C++ libraries, well, the build system and all that, automatically. So if you notice, it's the 2019 version, and it's the 2019 year and 16th version. Okay. So now, see, we just did that right there. So now let's do a cmake. Let's do a cmake, and we're gonna do a -- build, and what we're gonna do is put our directory is this current directory. So this is what it did. Let me show you what it did. When we did that, it actually built you a Visual Studio. It built you a Visual Studio solution. Okay, so you can actually go in here and click on the solution file in Visual Studio, and it'll pop up as if it's made for Visual Studio. So see how you have this right here. You can click on that solution and open in Visual Studio, which I don't. Because these files are kind of loose, I usually just use my Visual Code. But Visual Studio was helpful, and you can tie your cmake to the Visual Studio, do your builds and do your deploys. Okay. So what I'm gonna do is I'm gonna do a cmake -- build, and then on this current directory, and if you notice up here, it does have a cmake install. So this is generated for you. That cmake configuration right there. So what I'm gonna do is I'm gonna do a target, and I'm gonna do an install. Let's see what happens. See if it compiles right out of the box for me. When I did this before, I guess I wasn't reading directions properly, and it couldn't find the old libraries, but we'll see what happens. And this build, it takes quite a bit sometimes, but not really long. So let's see. So now what we're going to do is, while this build, what we're going to do right here is I'm going to actually run it and then pull it up. So it's going to build an exe file for me, and I'm going to actually run that exe file, and I should be able to get to the endpoint and test out the endpoint here. And out of the box, the when you pull down the Git, it actually comes with a route that's already put in, and it's in my controller. I'm gonna explain in maybe another video of the actual structure that you get out of the box, maybe in another video. It's like watching grass grow. So far, so good. And I can be getting this ready right now. Localhost 8000. That's the default port. If you notice, I had a solution earlier, right there. But this is later on when I actually incorporate the Swagger, and I don't want to use that utility to. There's a utility in there, but I don't like the way that it asks you to pull down other libraries from Git. It's kind of messy to me. And it should be done the right way, which is using like Conan or a package manager. So let's see what happens. Hopefully I don't have to do that. So far so good. Hopefully that's a good thing. And look like it installed the Oatpp for me. Yep, look like it installed it for me. So if I go over here to this build, I should be able to go to maybe x64. Let's see where that binary is. Okay, debug and maybe install. Let's try that first. Oh, let's go back. I might have to do a build all because I did the install. And so let's see. So what I'm gonna do is I'm gonna do the CMake, and I'm in the current build, and I'm gonna say I'm just gonna do a dash build, and see if it builds it out for me. Do a build all on it. See what happens. Okay, so there we go. So it did spit out the EXEs, and see how we got the debug in there. So let's see something. Let me make a guess. Let's see. Maybe if I go to, let's see where my EXE, did it say anything about where the other EXE is at? So I know in test, if we go up to test, and we go to debug, let's see what we got there. And see, we have the test.exe. So if I actually run this right here, okay, so it runs all the tests. Let's just take that out of there. Oh, I have to actually run the server in order to get it to pop up. It's running all the tests.